Alrighty, today we're going to be talking about average atomic mass and how we are going to calculate it. The learning target for today, I can use data to solve problems involving average atomic mass. Within that, you need to be able to do it correctly. Just simply find the average atomic mass. You also need to solve problems for mass of a specific isotope and identify an element from its atomic mass data. So let's do the calculation, tell me what element it is. So what average mass is, it's reported on the periodic table, and it is the weighted average of all the isotopes. Now hopefully you guys can see this. There's a few equations. The first equation that we're going to talk about is the mass of A times the percent of A plus the mass of B times the percent of B is equal to the average atomic mass. So if you are given percentage, you're going to use this top one. If you're not given a percentage, but rather you're given total number of atoms, you're going to use the bottom one, where you're going to take the mass number. Remember that mass number is protons plus neutrons. And you're going to multiply it by the number of atoms. And then you're going to add that to the mass number of the other isotope plus the number of atoms of that isotope. And then divide by the total number of atoms. So this is all because there are isotopes in this world. There's different stable forms of different elements. So let's do an example. First example, silicon-28 can be found in nature with a 92.23 abundance. 29 Si is 4.67, and silicon 30, I should say it 30 if you guys would add this, 30. Silicon 30 is 3.10%. What is the average atomic mass? It's the first thing we always have to do. We have to write down our given. So we know that silicon 28 has 92.23%. There's one isotope. Another version of the silicon isotope, version B, is silicon 29. So Si 29, and its percent is 4.67%. And our last one, C, make a little chart. C is Si 30, and the percentage is 3.10%. So what we're given here with these numbers and my 30 that I left out, this is the mass. So the first thing we got to do is set up our equation. So our average mass equals the mass of A times percentage of A, which is 28, because this 28 is our mass. So 28 times 92.23%. Now when we do multiply with percentages, we are going to move the decimal over 2 places, and we get 0.9223. And that will give us an answer of 92. 25.82. So you can tell that the majority of the weight comes from the silicon 28. So now we got to do B. We got to look at isotope B. Isotope B, the mass is 29, and the percentage is 4.67%. So we do 29 times 0.0467. Remember, percentage, we divide it by 100. And that is 1.35. Now our last one, we got to do C. Now C, the mass is 30. And the percentage is 3.10%. do 30 times 0.0310, and that gives us 0.93. Now, all we have to do is add the three of these up, and that gives us our total answer. So we'll do 25.82 plus 1.35 plus 0.93 equals, plug that into my calculator, and we get 28.1. So we know that our average atomic mass is 28.1. Now the units for atomic mass are simply AMU, atomic mass unit. And that is how you calculate the average atomic mass. We'll do one example in class, and then we will do a lab.